Financial modeling is often a manual process, an error-prone activity where an Excel expert is at the center of the ecosystem and is the filter of data going in and out of the model. So today, we're going to explore ways we can make the spreadsheet-based decision-making process more collaborative, automated, while at the same time enhancing data accuracy, data attribution, and securing sensitive information. And the question is now, how does your team make decisions based on Excel? So do you have a single Excel expert that builds the model, collects the assumption, crunches the numbers with Excel data table, add-ins for Monte Carlo simulations, risk analysis, and then goes into presentation mode? Now, most likely, most of the people have a linear process like that, because it's the ecosystem, it's the tools that are there, the technology stack that over the past decades has led us in that direction. And to change the way we approach tasks, not based on how well they should be performed, but based on the tools that we have available. And in reality, like any human process, the decision-making process based on spreadsheet should be agile. We don't communicate in a linear manner. We always collect in a conversation, we collect words, we collect hypotheses, we discuss them, we reframe our model of the world to communicate better and better and better in a very iterative way. Financial modeling, like software development before and many other company processes, has to become agile. And then the question is, what are the challenges for the main protagonist of this ecosystem to transform the process from a linear to an agile one? So first of all, the modeler is forced to be a bottleneck, and collaborators fear to engage. Why? Because the nature itself of the spreadsheet is pretty local. Doesn't matter how many ERPs and Power BI's collaborative things you have, your business case, you go back to Excel. There is no other story. Excel is the 2x2 comfortable representation of reality that we like to use. And think about it. Even management consulting frameworks tend to be 2x2. The most famous one is because we think that way. Because of this nature, the modeler tends to be the only one who really fully understands the model and can answer the what-if questions. All the others feel like they fear to engage with the model because they don't know what exactly to touch or what to look for. And without the modeler, the process stops. A way to solve this and to help the modeler become a value architect who takes care of the architecture of the model, of the high value added tasks here, is to enable others to self-serve safely on the model that they have built. So first of all, we don't have to take away the flexibility of a spreadsheet from the modeler. We just need to help them to transform that spreadsheet, which is a solo experience on their machine with add-ins which are local to that machine and so on, to a single source of truth in the cloud, which acts as a calculation engine for all possible assets that need to be connected to it. We also need to make people accountable for what they do. So if you think about the Google Sheets and Excel Online ecosystem, they tend to go in that direction of the single source of truth, but the last one wins. So if you had a beautiful scenario laid down there and somebody goes in and put a 5 instead of a 2 in a cell, that 5 will win. So you need accountability. You need to trace what people have done and know the versions don't really cut it. And I will show you why. So we need to show people only what matters. We need to give people a filter, an interface to only interact with what they need to interact with peace of mind, knowing that no matter what they do, they are not going to break other people's work. So now I'll show you how we do this on the platform. It's in the browser. It runs in the browser. So like when you log in, you would see a dashboard with all the projects. Some of them have been imported from Excel. So importing from Excel is as simple as going here, selecting the file and get it in. And here you will see your collaborators. But here, collaborators, as we will shortly see in the spreadsheet, take on a different granularity of sharing. not only viewer and editor, but only what exactly they can view and they can touch. This was a project imported from Excel with the formatting that was there in Excel. You have the comfort of recognizing your model. So apart from a few different things, but this is your model. And you can go back and forth. You can export back in Excel. You can give your clients the Excel version and Visyond version for the what if analysis, for instance. And this is all in all a spreadsheet. If you know how to write a model in Excel, once you have imported it, you can extend it in this platform without having to learn anything new. How can I, let's say, protect the spreadsheet from the people from spreadsheet, and having a world where the data entry person only sees the data entry worksheet, or the decision maker only sees the calculation, to avoid information overload, etc. The idea is that we can decide at a central level what each of the collaborators or the public link can view when they load this URL. So it's a unique URL from which you control everything as the project manager, the owner, call it as you want, but all others see what you assign to them. If I want Sarah to be my data entry person, she doesn't need to see everything, dashboards, etc. She just needs to see the data entry and, for example, no dashboards at all, because maybe they contain some analysis for company. And once you apply this, what you would see is that now Sarah has access to some worksheets and no dashboard. And when Sarah loads this URL, she will only see the data entry sheet. When people want to test numbers, stress test the model, what would they do? Well, you can expose for them the key drivers. Right click here, you say send cells to dashboard, and you select what you want. Here, for example, I like to have audit mode on, so I can see the nature of the cells, what is input, output, string, date, etc. And I like to have the names on, so I can see the formula in the natural language using the intersection between rows and columns. Now I've selected these three for simplicity, and I say, okay, I want to expose these three variables to the external world. I want to create a new dashboard, and I want to dump them here. And I also want to pick a chart that I've previously created in the spreadsheet. I'm redirected to the spreadsheet. Charts appear here, and I can pick up some charts that I've previously created. Let's see this one, for example. You click on it, you find it here. You can style this as a dashboard, sorry, as a slider, something else as a drop down, and then share it with some people. When you share it with people, they can use this as a calculator, okay, as an online calculator that can be embedded anywhere as well. This indicates that the cell is in what if mode. It's not synchronized with the spreadsheet anymore. They may not see the spreadsheet. They don't know the spreadsheet exists. We just tell them there is a calculation engine. If you want to synchronize with the base case, you click there and it goes back. 10 different people, 100 different people may have access to these slides based on what you do. And the numbers they stress test are local to them. So this is a virtual layer where when I change the sales volume in Germany on these slides to 5,900, if I go back to the spreadsheet that not everybody can see, remember, we still see 4,000. So that's the beauty of it. It separates the concern between writing the model architecture and letting anybody else do whatever they want at their own pace, in their own privacy, or at a conference, just by when they are challenged and ask a question like, oh, what if the cost of labor changes? What if the probability of lockdown increases? On a slide like that, unlike a PowerPoint, you can have a conversation with your model remotely without asking the analyst, without incurring into bottlenecks, and without the risk of, in a hurry, breaking the model if you want to add a new assumption. So another problem we have, and you may already have an intuition for how this is solved, is the version chaos. Because Excel is a local experience and Excel Online is a version local experience, you need to have naming convention. You might be familiar with something like this, final, updated. Even if you are the solo modeler here, you need to keep a change log just to make sure that you keep track of the information, the assumptions they have put in. And in order to solve that, besides this granularity of sharing, even when Visyond is shared with people who do have permission to change things in the spreadsheet, we always pay attention. Am I trying to override somebody else's information? And if the answer is yes, Visyond will automatically create a scenario for that. So nobody, even if they want, can accidentally overwrite other people's data, can break the model. And we track this data. I will show you now how this is done. So let's say that you are in a meeting room with somebody, or you ask somebody to contribute, and these people don't believe in this sales volume. So the simple thing you can do is to add a record, a scenario. So you might be live in a meeting room, so you don't need to send the modeler back to her desk and make another appointment just for this, because she needs to manipulate VLOOKUP functions, complex if functions with flags to pick up a certain set of assumptions. No, you don't have to do that. So for example, we want to branch from the base case or from the current case. We can extend the current case. Imagine you have an actual scenario on a rolling basis. You extend the current actual when new data come in. And let's say that we want to branch from the base, and we say at the summit. So we call this scenario at the summit. Now we are in recording mode, and you are free to do whatever they want. So you can say the sales volume is 5,000. Here we have 220,000. Here the head count is going to be 70. Here is going to be 75. You name it. You can go on as much as you want live, then you save it. And what you have here is the active scenario is at the summit. But if somebody broke something in this scenario, you can always go back and say, oh, I want to see the scenario with investor by George. That's what I liked. Cells will reconfigure. You don't need to go back to mysterious versions that were taken in the past. You have everything in front of your eyes. And if you go to the overview, you have the data tracking part, which will show you all the scenarios, for example, all the assumptions, the cells that are driven by this scenario, on which assumptions they are set. So you have a full data tracking of the contribution. And after you have created the scenario, you can go to the analysis part. You can go to the scenario comparison. I will show you the rest later on. These are scenario comparisons that have been done in the past. You see, you can click and see what your colleagues have done. Think about the self-service and the ability to build on others' intuition, on others' analysis. Like Alex compared these scenarios for the net profit. Okay, now let me see Alex plus Alex set of scenario, but I also want to see the one we just created at the summit. And am I okay with the net profit from year 0 to year 6? Let me go back, pick it up. You're taken back to the spreadsheet. Actually, I just want to see 4 years, not 6. You pick it up and you compare. Yes, I want to override this analysis. I'm fine with it. And here you go. You can give it a name and save it and discuss in real time on a flat screen the scenario you have just created. And so you have all the scenarios here with the variance table, and you can export this either to PowerPoint, for example, or to our dashboard. So if you export that to our dashboard, a dashboard gets automatically created with some dummy text that you can edit, and you can share this with decision makers, for example, saying, okay, these are the scenarios. They can watch this on their iPad, for example. Besides showing them the scenario comparison, again, I can rebuild that small calculator. Let's pick this time we want also the head count. And this time, let's look at the net profit. You are done. And here it is. You share it. People will load this URL and will play with the numbers without breaking what you have done and only seeing what they need to see. And here they see that they are in what if mode. So that's the way we solve the version chaos. And you have seen how this also solves the problem of potentially corrupting the spreadsheet and exposing sensitive data, because you may use techniques like locking the worksheet. But even if you lock the worksheet, you go on YouTube videos on how to unlock It's not complicated. And in any case, people see everything. They see all or nothing. So we go beyond that. And another technique that people use is to create sanitized version of the model, so that they can share this with people who are not supposed to operate on something. So they need to get back the spreadsheet and plug manually back in, or with some sort of automation tool made by programmers to plug the numbers in again. It's very time consuming, error prone, cumbersome. Visyond solution of sharing selectively only what people need to see, and not allowing people to overwrite other people's data, because we create a layer immediately which is assigned to that person, and that person is accountable for that layer. So they cannot tell you anymore, I didn't give you this assumption, etc., because it's captured right there. And they have a safe layer where they can play with numbers. Identifying opportunities and risk can be cumbersome. Why? Because of course, most of you as modelers know how to do Excel data table for sensitivity analysis. Many of you use VBA macros. The bankers might use Python, R, add-ins, which are local. Of course, they are not portable. We go back to the problem of locality of Excel. And taking data from Excel to a visualization tool usually loses that connection between the input and the output cell formula. So you go from treating data like revenues as depending on volumes and price, to revenue as a data point to which you can do a plus minus 5%. So you lose the insight into how revenues are what they are when you take, let's say, data outside of the spreadsheet world. And finally, you have this problem of static presentation, meaning that you can copy paste as many scenarios you may anticipate. But let's say the problem of having a curved ball, a difficult question at an investment committee, or with a decision maker that asks that what if question you could not foresee. And so you have seen that the way we transform this ecosystem into a self-service one, where the modeler creates the architecture. The intellectual property of the modeler is the connection between input and output. Then there is an auditor that, using our tools like auto-formatting, will see if there are any anomalies. We have anomaly detection. If you go to the spreadsheet and you are an auditor, for example, here, you will see when you go into audit mode, you right click and you say, okay, what are these borders? And you say anomalies and error. Dollar sign mismatch in adjacent cell. So you look at it and you see, this is a formula. Here there is a dollar. Here there is no dollar. Let's look into that. Okay, it's not, maybe you did it on purpose, maybe not, but at least Visyond gives you some flags to watch. The key is that people here should be able, through a URL, to self-serve on the parts of the model, or to contribute only on the parts of the models that you want them to contribute to. I would also argue that the non-agile spreadsheet-driven decision-making has high costs. Sometimes we don't see them, but they are there. I mean, how many times I've been sent back to rework my model, to incorporate additional series of assumptions and additional scenario, etc. That back and forth, it's costly. And every time I did that, I felt the risk of introducing errors that previously were not there, because auditors are not always available to redo the full job every time. There are add-ins costs. For example, if you look into Monte Carlo simulation, you may use Oracle Crystal Ball, you may use Palisade at Risk, which is local. It costs a few thousands a year. It works on your machine. It doesn't work on the version for Mac. Now, all this, let's say, sensitivity analysis, you can have them embedded. Let's say your decision metric is the net profit in year 5. You can position yourself here. You can right click. You can click on auto analysis. And what auto analysis will do, it will scan the model by the time you go for a coffee, and it will tell you, okay, this is a small model, so it's already done. What it is telling you is that for the net profit in year 5, the top 3 input drivers are these 3 guys here. So you know that before somebody challenges you on any other cost driver, you better make sure that these assumptions are right, because they drive most of the variability of your decision metric. Also, if you go to the analysis part, that's what Tornado tells you. Basically, Tornado will tell you that for the net profit, the most important input drivers, guess what? Average price, sales volume. So when these parameters change by plus minus 10%, and you can change this and rerun, by the way, you want to change the parameter by a different percentage, do it. When they change by plus minus 10%, the output, the net profit changes by plus minus 44. So you need you see the amplification of any potential errors in the assumption here. And this tool also help you uncover logical mistake. One time a customer said, oh, I think you have an error in your Tornado because I go here and I don't see this cell. And actually, when we went to the cell, so by clicking here, you are taken to the cell. This client had a white cell here. I said, how is it possible? The problem is that the consultant they hired, they hid this cell with white font on white background, and it was a cell used to as a plug for the model. I mean, very bad stuff, but it could genuinely uncover logical errors.